Good morning, class 7. Today I'm going to show you the part 2 video of the lesson heat. Let us first recall what we have learned in the previous video. We have learned that heat is a form of energy. The hotness or coldness of a body is its temperature. We use a thermometer to measure temperature. Clinical and laboratory thermometers are the two main type of thermometers that we use in everyday lives. Celsius, Fahrenheit and Kelvin are some units to measure temperature, Kelvin being the SI unit. These days we use thermal scanners and digital thermometers to measure the temperature. So far we have learned this. Let us now continue about heat. In this video, we are going to concentrate on how heat is being transferred. Look at the picture on your left side. What do you see? You see a pan which has got some water and which is placed on a burner. So how do you think the water is going to get heated? The plan is to heat the water, isn't it? So how is it going to get heated? So as soon as you switch on the burner, what happens? The heat from the burner is transferred first to the vessel. First the vessel only will get hot. If you put your hand in the water, you can still put it. It will be cold only. Slowly as the time passes, the water begins to heat. So where did the water get the heat from? It got it from the vessel. Where did the vessel get it from? It got it from the burner. So the heat is transferred from the burner to the vessel, from the vessel to the water. So in other words, heat can be transferred from one object to another. There are basically three types of heat transfer, three methods or modes of heat transfer. What are they? They are conduction, convection and radiation. So what are the three methods or three modes of heat transfer? They are conduction, convection and radiation. Let us study more about conduction. Coming back to our picture. Okay. So what do you see here? So from the burner to the vessel, what is happening? Heat is being transferred. How it is being transferred? Are they in contact? Yes. The burner and the vessel are in contact. Which is at a higher temperature? The burner is at higher temperature. Whereas the vessel is at lower temperature. So heat is being transferred from the burner to the vessel and not vice versa. So these are the two conditions required for conduction to take place. That number one, the two objects should be in contact. Second condition is the two objects should be at different temperatures. Then only heat transfer can take place. If both the bodies are at same temperature, no heat is transferred. These are the two conditions. The most important thing that you have to remember in conduction is the molecules do not move. Only the heat is transferred. Okay, imagine you are playing passing the parcel. What happens? Children remain in a circle in their places, but what is being passed? A parcel is being passed from one child to another. So in conduction also same thing happens. Heat gets transferred from one molecule to another, but the molecules themselves do not move. Here is an experiment to understand conduction better. So what is the setup of the experiment? I have taken a copper rod. Okay, what I have done, I have taken a copper rod. Can you see the copper rod? One end I have fixed to a stand. Okay, on the other end, I have placed a burner. When I light the burner, what happens? Heat gets transferred from the burner to the copper rod. Okay, immediately, directly here it gets transferred. Then from this place on the copper rod, the heat gets transferred to this place and eventually this. So it comes to candle number 1. Since the candle is attached with the help of wax, the wax melts and the candle falls down. Now heat continues to travel and reaches candle number 2. The same thing happens. Next, candle 2 falls down. The heat continues to travel and reaches candle number 3. The candle number 3 too falls down. The heat continues to be transferred till it reaches the very end of the copper rod. This is how heat gets transferred in conduction. So, what is the definition of conduction? Conduction is a method of heat transfer with the help of a medium from a source of higher temperature to always a source of lower temperature. This is the definition of conduction. It is a mode of heat transfer mostly occurring in the solids, but it requires a medium, and heat is always transferred from a higher temperature to a lower temperature. Example just now what we saw. Okay, let us see the examples on the right hand side of your picture. You see conduction taking place. See, a bowl of hot soup is there. You put a metal spoon in it. What will happen to the metal spoon? Gradually it will absorb the soup's heat and become hot. Similarly, the a rod being heated on a candle. Okay, so that heat is being transferred from the candle to the rod till it reaches your hand, and when it becomes too hot, you most likely will drop the rod. And the third example is every day this happens in your kitchen, rather in your mom's kitchen. Okay, heat is transferred from the burner to the vessel, the pan, the dosakallu or whatever mummy has put on the burner, and from there heat is transferred to the food, and that is how it gets cooked. So these are some of the examples of conduction. Now, how does conduction actually work? Conduction takes place very well in solids. So, land will get heated very fast, as well as any metal. Okay, metals like iron, copper, steel, etc. But conduction does not take place very well in liquids and gases. That is why air and water do not conduct heat very well. Remember this. This is very, very important. Remember that air and water do not conduct heat, whereas land gets heated very fast, and so do metals. The most important thing that you have to remember in conduction is the molecules do not move. Since it's a solid, remember, most of the conduction takes place in solid. In the solids, what happens? It is very, very tightly packed and they cannot move. That's why they can only vibrate, and this vibration is passed from one molecule to another. But the molecules themselves do not move. Now the next question arises is, do all objects conduct heat? Let us understand with the help of this picture. What do you see in the picture? You have a bowl in which I have poured some hot water and I have left 3 spoons there. You see a wooden spoon, you see a metal spoon, and you see a plastic spoon. Which do you think will get heated? Yes, you guessed it right. The metal spoon. Do the wooden spoon and the plastic spoon show a rise in temperature? Do they get heated? No. It means that all the objects do not conduct heat, do not allow heat to pass through them. Hence, the objects that allow heat to pass through them are called as conductors, just like this metal spoon over here. Objects that do not allow the heat to pass through them are called as bad conductors or insulators, just like the wooden spoon and the plastic spoon over here. Let us see some more examples of conductors. Can you see? Rods, vessels, a frying pan, all of them. What is common among them? Most of them are made up of metals. So all metals, okay, iron, copper, steel, brass, aluminium, all of them are very, very, very good conductors of heat. And this is the reason why, if we want to heat anything or if we want to cook anything, we use these metals to make vessels out of it, be it a frying pan, be it a cooker, be it a milk cooker, anything that we want to cook or heat, we use a metal conductor. Let us see here some examples of insulators. Remember, insulators are materials that do not allow heat to pass through them easily. Have you seen a cooker? Your mother daily uses it. What is it made up of? Either it would be made up of aluminium or steel. But what about the handles? Are they also made up of metal? No, isn't it? It is made up of some black color material which you can easily touch even if the cooker is hot. So that is an example of insulator. The black material which makes the handles of cooking vessels is actually a material called as bakelite, and it's a very good insulator. Similarly, after making chapatis or idlis, your mother will put them in a casserole. Have you wondered how the casserole is able to keep food hot for you for a long time? No, no, no. It is not magic. It is science. In a casserole, there are actually two layers. Okay. In between these two layers is a very, very good insulator. So, the hot food does not allow the heat to escape from the casserole towards the outside. Similarly, in a flask, if you have some cold drink, it will not get very hot very fast. Why is that so? Because the vacuum flask does not allow the outside heat to get into the flask and heat your cold juice. So this is how insulators are very, very important for us so that we can keep hot things hot and cold things cold. Let us now understand the second method of heat transfer, which occurs in fluids. We call this as convection. What is fluids? Fluids is nothing but, remember, gases and liquids. Take a look at the picture on your left side. What do you see? You see a beaker full of water which is being heated with the help of a Bunsen burner. Okay, once it begins to heat, what do? I drop a few crystals of potassium permanganate. They are a beautiful violet color. After dropping them, after a few minutes, what will you observe? You see a purple color water column rising from the bottom, reaching to the top. Now, why do you think this happened? Can you explain this? The explanation given is very, very easy. The molecules at the bottom of the burner, they absorb the heat from the burner and become less dense. They become lighter and they begin to raise up. Since these molecules have the color of the potassium permanganate crystals, so you see a column of violet rising to the top of the beaker. What happens to the cold water at the top of the beaker? It being denser, because it is cold, it begins to settle down. So this cold water again gets heated, it raises up, and the next molecule of cold water again drops down. And this continues, this chain, this cycle of movement of water molecules continues till all the water in the beaker is hot. So if we want to define convection, we can say that it is a transfer of heat in a fluid, that is a gas or a liquid, as a result of the movement of the molecules. Here in convection, heat transfer takes place due to the movement of the molecules. Okay, the molecules actually move in order to transfer the heat. Example of convection is boiling water, and it could also be wind currents or ocean currents. So how does convection actually work? Just now, as I explained to you, the molecules move. In convection, whether it be a fluid, whether it be in a liquid as in water or air, the molecules of the water as well as the molecules of the gas actually move in order to transfer the heat. Some examples of convection are hot air moving inside a building, water boiling, or your sea breeze and the land breeze. Some applications of convection. Have you noticed how in villages where they do not have very good electricity, or people who cannot afford to have ACs, they tend to have very, very high ceilings? Okay, if you have seen if you have been to an old house, you might have noticed that the ceiling is very, very high, and very near to the ceiling you can find some ventilators. Now, why do you think these ventilators are up there, high up there on the wall? Just now we learned that hot air always moves up. So, whatever hot air is there in a room, it will move up. And gradually, if you have ventilators there, it will move out. And if you keep the doors and windows open, the cold air being heavy, which will be near the ground level, will move in through these doors and windows and will actually help you to keep the house cool. The central heating that you see in modern apartments and office buildings also is based on convection currents. First, in the previous previous slide, I told you that sea breeze and land breeze are examples of convection current. This being very, very important, let's understand this in little bit of detail. Okay, so what is sea breeze? Sea breeze is a breeze which flows from the sea towards the land. Okay, when does this happen? It happens during the daytime. So, what happens during the daytime? Daytime, the sun is nice and up. It gives heat to the sea, it gives heat to the land also. But the land heats up very fast. It becomes hot very, very fast. And similarly, the air above the land also heats up and starts to move upwards, leaving an empty space over the land. The sea being cool, there is lot of air very near to the sea, and this cold air immediately rushes to take this empty, to occupy this empty space. See the direction of the wind? From the sea towards the land, and that is why we call this as the sea breeze. Now let us understand what is a land breeze. Land breeze occurs during the night time. During the night, the land cools down very fast, whereas the sea is still warm, and it also heats up the air above the sea, which again begins to rise up, leaving an empty space. Cold air from the land rushes to fill the space, and we get the land breeze. So during the daytime, you have the sea breeze which keeps the land cool, and during the night time, you have the warm land breeze which keeps the coastal areas pleasant. So in the morning, it is not very hot. At the same time, at night, it does not become very cold. So sea breeze and land breeze help the coastal cities have a very pleasant climate. Let us move on to the third mode of heat transfer. We call this as radiation. Have you ever been to a campfire? Especially in the winter months on the 31st December, or if you have been to a hill station during the winter months, you put on a nice cozy warm fire and you sit around it. Even though you're not touching the fire, you can feel the warmth of the fire, isn't it? So, how does this heat travel? You're not touching, there is only air. Air, remember, is a very bad conductor of heat, but still you get the heat from the fire. How do you think you get it? So, here the heat travels like electromagnetic waves and reaches you. And this is what is radiation. So, heat transfer in the form of electromagnetic radiation is called as radiation. This is the only method of heat transfer that does not require any transfer medium. So, this heat transfer can also occur across vacuum. This is the reason why the sun's heat can travel across the empty space, across the vacuum, and reach you. You know in what time? Just in 8 minutes. And this is the very basis of life for us. Here are some applications of radiation. So, all bodies radiate heat, but some bodies radiate more heat and some bodies radiate less heat. This radiation, interestingly, has got something to do with the color. Can you see the picture on the left hand side? You see a girl wearing two uniforms. Okay. One is a summer uniform and one is a winter uniform. Can you guess which is a summer uniform? Yes, you guessed it right. The light color dress is the summer uniform. Why do you think she wears a light color dress in a summer? Because light color does not absorb heat but it radiates heat back, keeping the girl cool. But in the winter, look, she's wearing a dark color shirt and a dark color jacket. So, this dark color helps to absorb the warmth around her and helps her to keep warm. Another example of application of radiation could be the color which you put to the outer walls of your houses. In hot countries like India, we tend to put light colors to our wall. So, is there any reason behind it? Yes, the reason is very simple. If you paint the wall, exterior wall white, it will radiate all the heat and the walls themselves do not get hot, leaving the house cool. But on the other hand, if you paint a very dark color, it will absorb the heat, keeping the making the house very hot and uncomfortable. So, to conclude, let us compare the three methods of heat transfer. We learned that there are three methods of heat transfer. They are conduction, convection, and radiation. Conduction is the transfer of heat directly, where only when the objects are in contact, directly in contact. Convection occurs in fluids, that is gases, and in liquids, and here the molecules move, whereas in conduction the molecules do not move. And in radiation there is no medium required and heat transfers in the form of electromagnetic radiation. This is how you get the sun's energy. Hope you understood the methods of heat transfer. That is all in the lesson heat.